What the sock? Welcome to quote final review real one. Let's just get this over with because it's like 4 problems. No. Anyways, multiply and simplify. So first, we're gonna make this easier and like factor the different parts of the fraction just so that it's like easier to multiply and stuff. So like first let's factor this so we can take out 4p. So I'll just rewrite it over here. We could take out 4p, which will leave us p plus 8. Yep. Over, you can't factor p minus 2, so we'll just leave that. And then, sorry, I lagged. For this, we can, like, factor it, like, I forgot the equation type, but we can factor it like that, okay? So the factors of 6 are 1 and 6, which won't work, because the p right here is a 1, and 3, 2, which will work, so in order to multiply to get -6, one of the numbers has to be negative, but they have to equal a positive 1 when they're added together. So we will do a positive 3 and a negative 2. Yippee! So p plus, what the freak? That's not a p. What? P plus 3 times p minus 2. So ready for the end of the school year. Okay, here we can take out, well, I know we could take out p to the power of 2, and we can take out 2. So 2 p to the power of 2. So there's 1p plus, and then 16 divided by 2 is 8. Wow! Yippee! Okay, let's put these all together real quick. So p, oh my god, what the was it? Plus 8. So times p plus 3 times p minus 2 over p minus 2 times 2p to the power of 2 plus times p times 8. Okay, now what we could do is we can look for stuff that cancels out. So here at the top we have a p plus 8 and we have a p with plus 8 right there, so that cancels out. And then we have p minus 2 over here and p minus 2 over here, so that cancels out. So then we have 4p times p plus 3 over 2p to the power of 2. Okay, so technically this p right here is 2 p's times each other, because that's how exponents work. So then we can cancel out 2p from the top and the bottom, which will leave us 2 on the top. So then we have 2p plus 3 over p. Pretty sure that's right. Yeah, that's right. I've been checking my past work. Anyways, a research study in the year, oh my god, my head. A research study in the year 2000 found that there were 440 coyotes in a given region. The coyote population is expected to grow at a rate of 17% each year. What is the coyote population in 2006? Okay, let me cook. I'm not gonna cook. Okay, so this is our starting number. We're gonna do p for population. So this is our starting number, 440. Then we're gonna multiply it by 17%. So as a decimal, 17% is 0.17. But it says here that we are growing. So in order for our equation to actually show growth, we have to add a 1 to it, making it 1.17. So we're multiplying 440 times 1.17, and then to the power of years. So, yeah, you get it. Okay, so we're going from 2000 to 2006, so then that would make our years... So we are doing it over the span of 6 years. And I'm going to pull out my calculator for the exponent because I'm not doing all that in my head. Okay? Or on paper. No, wait. So, it's a really big number when you, or not really big, it's a really long number when you put it to the power of 6. So, but it says to round to the nearest whole number, so we'll just round to 3. So we got 440 times 3. And that would equal 1,320. In the 20s! Sketch the functions. Oh man, this is the one I didn't like. Okay, we're gonna do this differently. Let's color code everything. This function will be Urple. This function will be Weezer Blue. Yes, this is actually color picked from the Weezer album, so when I say it's Weezer Blue, it is Weezer Blue. And then we're gonna do this pink. Ooh. For the first parent function. And we're doing green. Okay, and the second parent function is in green. That's a okay. So let's graph this parent function first. So when x is at 0, y is at 1. And when x is at 1, y is at 2, of course. And when x is at 2, it's 2 to the power of 2, so that means it goes all the way up to 4. When it's at 3, it's all the way up to 6. Pretty sure that's 6. 6. It's at 4. No, it's not up to 6. What? It's at 8, idiot. Okay. And then that's, like, generally how it looks. It's never going to touch right here. It's never going to touch the x-axis. You know? Because you can't, like, use an exponent to get to 0 or below 0. I don't think. Anyways, let's graph the purple function. So now there is a negative there in front of the 2, so that means it's flipped over the x-axis. And then the plus 3 next to the x just moves the whole equation over 3. Okay. So 1, 2, 3. So the x is it's basically our new y-axis. Right? No. What? I don't know. Just roll with it, okay? Okay. Great. This is amazing. Now, let's do our green parent function. By the power of Ra. So, when it is 1/2 it basically flips over the y-axis. Okay? Okay. You get it. You understand what I'm saying? Like, it flips it. Pretty much, yeah. We're gonna say it flips it. I sound crazy. But, yeah. Okay, now let's do our wizard function. So, the negative in front of the x flips it again. What? That's crazy. And then +1 moves the whole equation up 1. So now we're starting here. And then the new x-axis is going to be right here. So it never touches that line. Okay, great. That's the second to last problem. Now we have one more. This video is going to be so long. Okay, so find the inverse of the function. The inverse, it's basically the opposite, okay? Like how you, like on the last one, you know how we had 2 to the power of x and then 1/2 to the power of x. They're basically inverses, but not really. But not really. I'm saying dumb stuff. I'm going to lose my mind. So we know that f of x is y. So in order to find the inverse, what we can do is we can swap the places of the x and the y. And we have to try to get y by itself again. We multiply each side by 4. So we got 4x equals y minus 3. Then we add 3. 4x plus 3 equals y. That's our inverse. You can write it like that, make it easier to understand. But yeah, that's our inverse. And that's it. Bye.